Let's do another example. Okay, all right, so this is the next example. So again, here, right, we have this polynomial that we want to factor. It's 4 terms, right? So because it's 4 terms, that's how we know we're going to use factor by grouping. And so just like before, we want to figure out what the one step too ahead. We want to figure out what the GCF is, the greatest common monomial factor of the original. Well, notice that there's a non-zero constant term, so we can't factor out an x at all. If you were to look at the factors of 7 and 5 alone, you would see that these two numbers alone only have 1 as a common factor. Well, that tells you the greatest common factor among the coefficients and the constant term has to be 1. It's the only factor they all have in common. So the GC, so that's what B is here, right? And as I just said before, M is 0. Remember, the GCF is always B times x to the m, where x to the 0 is 1. And m is 0 because, again, we don't have an x here. B is 1 because, again, the greatest common factor of the numbers, that's going to be 1. So the GCF of this is 1, and we don't take anything out. So what do? Well, what we do in factor by grouping is we're going to form 2 groups of 2. Now notice something else I also did here. Here we had subtraction, right? What I'm doing is I changed it to addition. I mean, that just makes it easier when I form these groups. Mostly because of the minus sign here, you have to be careful when you put parentheses in. By making it into addition, it makes it a little bit easier. Okay, so again, for the third term here, I mean, you don't really have to do this, but you do have to be careful. You want the third term to be addition. All right, so that's what we have here. Okay, so again, we have to handle each group individually. And notice also that the second term and the fourth term tell us we will have to factor out a negative from here, from this group. But we'll get to that shortly. So let's handle this group individually. So let's handle this little mini group, so to say, first. But again, right away, we can see that the smallest power of x is 2. So for this alone, we can find its GCF. So we have 2. That's the smallest exponent of x. Excuse me. Here, I'm just listing the factors of 28 and 20 because we want to get the biggest common factor among these numbers. And as you can see, that turns out to be 4. So we have a 4. We have m equals 2. Again, this is what the GCF of any polynomial, in this case, this little group here, looks like. So we're going to factor out 4x squared from this group. Again, we're just taking out common factors from the first group here. That's all we're doing. And so we get 4x squared, right? That's what this work shows, right? Because the smallest power of x is x squared, m is 2. The greatest common factor of the numbers is 4. So we're factoring that out. Factoring it out, this is what we get, right? You have to divide to see what's left over. And when you divide into a sum or subtraction, you divide into each term. And so we get this, right? 28 over 4, that's 7. X cubed over x squared, you subtract the exponents, you get just x. Here, we have x squared over itself. X squares cancel. 20 over 4 is 5. And this is what I was just saying before. We have to factor out a negative from the second group. Now here, I think I made a mistake there. Here we go. Here we go. Okay, so here we have to factor out a negative from negative 7x plus 5. Okay, so that's what I'm doing here, though. I'm factoring out negative 1, as you can see. Okay, this line, let me just fix that. Yeah, let's just forget this. I mean, it does turn out that 7x minus 5. Well, yeah, let's just skip. Here, forget that line. That's a mistake. Here we go. So for the second group here, right, let's factor out negative 1, okay? And that's what we're doing here, right? So negative 7x over negative 1, 5 over negative 1. Remember, you divide to see what's left over. And when you divide, you end up getting this. Here, I'm just using sap and sun rule. Signs are alike, positive. Signs unlike, negative. But notice now, by factoring like so, we end up with this, right? From the first group, from a few slides before, we got this. And from factoring here, we get this. And notice we have a common factor among both these groups, right? 7x minus 5. And that's really what you want. You want to make sure you have something in common with both groups. In other words, what's in the parentheses here, you want, right? You want something you want what's in parentheses to be in common to both of these groups. And now we can factor that out. And that's what we're doing here. Right? So we're going to factor out this. And again, we're dividing to see what's left over. And when you divide, there's going to be some cancellation. Here, let me just go back and let me show you the cancellation. So for instance, this will cancel with this. Right? These are the same, they cancel. Same thing over here. So what we're left with is the next line. And then instead of leaving it as plus negative 1, I wrote it as subtraction. That's all. I mean, if you left it on an exam as plus negative 1, that's fine. But altogether, we end up with, but this is what we end up with. And now 4x squared minus 1, you can actually factor that further. Namely, that's what I get over here. And I'm just using this formula, so that's all I'm using. It's actually a difference of 2 squares is what I'm using, but I'm using this formula here. Namely, you could take A to be 2 and B to be 1, and that's what I'm doing. So here, let me write it out. So we have 2x, let me put it in parentheses, squared minus 1 squared. And that's really what I have up here. Okay. All right. And altogether, of course, this is in the way. Altogether, this is what we get. Again, this was the 7x minus 5. Here we had the 2x minus 1. Okay. Let me just make sure. Okay. Is everyone with me so far? I feel like that one was, Let me see. Let me make sure. No, wait, not that. Just pause the recording.